Yeah, the high level agenda is like, I'll set some context. Like last time I shared much more around distributed systems, how we can split, like similarly, like we sort of touched on monolith and then how we can go to distributed event-driven systems and stuff like that. Probably I can show that, like, even if I don't have the content right away. But yeah, like thanks for being here. I'll get started. I'll just things around. Cool. So you can see my screen, right? You're able to see my screen?
Yep.
Cool. Awesome. So about me, like why you should listen to me, like I've worked in a company which is like Uber kind of a scale, where I manage Kafka cluster for like a billions of transactions. And then like I've seen the evolution like from over multiple years, and then how like Kafka largely helped us. So I'm a huge fan of Kafka. And then like in my later companies, we didn't use it as extensively, but I'm still in touch with the ecosystem. And then like that's why I came to Vancouver, and then I saw, hey, we should do more of Kafka meetups, and then I've been also part of few. So yeah, like I've worked in really high scale systems in the past. If there's anything else like specific questions or based on like my work, happy to share more context on that. But yeah, like that's about me. But the agenda is, as I said, like we'll touch on basics, we'll touch on Kafka terminologies, and then we'll talk about some producer consumer and aspects of it. So in the meantime, feel free to drop any questions you have regarding Kafka. So that way, like I can cover the same thing in basics. And then like if it's too much out of the scope, I can actually cover it at a later point of time. I think this is something like I always want to have. Like it doesn't matter what system we are building. You always have to assume things will fail. It doesn't matter what scale, like whether it's a monolith, whether it's a distributed system, whether it's on Kubernetes. I always think that it's going to fail. It's just that a matter of where the bottleneck is and how you're going to fail. So in that sense, in this talk, like that's why I mentioned, hey, how do we use Kafka? Like Kafka helps us in a large extent to remove some failure points, but still in order to use Kafka properly, we still have to adopt some practices. So that way it's much more reliable. For example, payment scenarios could be very different than a regular location-based services. So we'll touch on that. So super high level context is, in terms of monolith, you would be handling not necessarily events, but you would have an API, and then you would be dumping events to database, and then you will be calling some microservices to process or orchestrate things. But in terms of Kafka, the whole philosophy changes, right? It's like you operate in terms of events. It's more of a distributed system where you will have everything eventually consistent versus everything is a synchronous API. So that's sort of like where Kafka like shines, I would say. Like even if you have 500 microservices, it's not going to affect a single API call. Like you sort of change your architecture in a way that it allows scaling, and then it allows much more reliability and whatnot. I think I can show the previous thing. Let me just see whether I have it. Yeah, I have some aspect. Can you see my screen as well? The Excalibur? Yeah, okay, cool. So let me just see. So, I mean, like since folks are new, I'll just give context, right? Like assuming you will have a monolith system like this, usually the bottleneck is going to be a single service. Like in your case, monolith, you would have already seen that. But there is also much more need for splitting services, right? Like it's not just a concept of microservices, but let's say, hey, I always feel like the driver service, like, I mean, this is in domain context of it could be a food delivery, it could be a Uber rides, it could be any ride hailing apps, like where you have customers and driver and some sort of orders. That domain is what I have referred here. The driver service is usually less loaded in comparison with customer service because you will have millions of customers whereas few lakhs in drivers, and obviously that is like exponentially mapped to like the transactions and then whatever it does, right? So in this sense, you would have a bunch of APIs, but here it's sort of split into multiple services. And then still, if you end up calling microservices like each other, the load will just shift from one service to a different point, possibly a single database, or possibly like that particular service can't scale. And also, it doesn't allow you to extend the service. That is the much more critical point. Like let's say, hey, in this case, I want to add promotion, or I want to add a email once they sign up. And then I also want to add, hey, there is this trip, we have a 50% off. All this could be new service rather than you touching customer service. That doesn't require a deployment and then like rollback, stability, all of that, right? Like that's the microservices funda. But even without HTTP API dependency, if you put that in events, it is much more isolated and independent. So customer service doesn't even have to worry about, hey, there are this XYZ services where I have to orchestrate, but you just send an event whenever an order is created, and then anybody can consume it, and then they can operate on it. It could be driver service, which is doing critical transactions, assigning a driver to an order, or it could be a payment service, or it could be even a, let's say, promotion service. This sort of architecture evolves with like a distributed system. And this is something you can do with any PubSub system. And Kafka has much more nice parts to like how consumers deal with things, how producers deals with things. But yeah, we'll touch on it in time. But having said that, like keeping microservices aside and all of it, the Kafka is a PubSub mechanism where it allows you to have multiple producers and then multiple consumers. That's super high level. And it's not just one topic. Like topic is, you can treat it as a queue in other mechanism, like a list in Redis, something of that sort. Here, orders is a topic, location is a topic. It's just a group of messages. And then you can have multiple producers pushing to a single topic. And you can also have multiple consumers consuming from that topic. Yeah, like this architecture, if you have not touched Kafka, like, of course, there's a lot of nitty-gritty details where the consumer can consume from multiple topics. There is this consumer groups and all of that we'll touch on. But the core is like a topic is not just in a single location, whereas it's distributed. So it allows you to scale from like few K messages to millions of messages and whatnot. So I think producer, you're all aware, consumer is just in the inside of it. Topic is just a bunch of messages. Consumer groups is like, I mean, let's take the same example, right? Hey, for every order, I need to send a promotion. But if you have a lot of orders, you can't have a single service dealing with it. Like just like how you have replicas in Kubernetes or multiple instances of service, all of them needs to consume from the same order, and that should consume distinct messages. For example, all of them shouldn't be consuming order one. The service one should consume order one, the second instance should get order two, and the third instance should get order three and whatnot. So that is like a bunch of consumer consuming from a particular topic. And that sort of allows you to scale. Like I'll sort of stop here, like, because if somebody is not in line with this, like shoot me any questions, and then like we can ensure everyone is on same page, and then we can move on. Any questions so far?
Nope, that's clear to me.
Okay, awesome. So now let's talk about producing messages, right? So we'll start with a simple use case. Same, like, hey, we create a consumer service, we have a customer service, and whenever order is created via an API, we just send the message to Kafka. And then ACK is a means of acknowledgement where we know that the Kafka received the message successfully. And then like you have to move on. But the one issue here is the failure can be at any point where, sorry, like I just added a random thing, like it could fail in ACK or it could fail in message itself. I wanted to put the like a failure acknowledgement where it's possible to have a failure either at a message publish side or even an ACK when you send it back to the producer might have died. So in that sense, it's still treated as a like a tricky thing where, hey, there is a possibility of message loss, and then at which point it failed is still unknown. And then let's say, hey, if you add on to the additional functionality of what do you do on top of with it, right? Like it's not just you send message to Kafka, but you also have to do some operations in a database. In this case, it could be, hey, create an order, associate with a user, and then update timestamp. Would you do it like beforehand or would you do it afterwards? Like there is multiple options, and that sort of defines how like the failures can be treated. So I mean, like I'll not even touch this, but let's say, hey, have anyone sort of like used a mechanism where, hey, you send a messages to Kafka, and then like, do you think would there be any failures with this, or like, is there anything we need to handle here? I see a question: what happens to event when you acknowledge it? Does Kafka discard event, or does it still exist? So the acknowledgement is just purely. I mean, we'll talk in detail about acknowledgement, but in Kafka, like we are not even touching what is Kafka infrastructure, like how brokers and all of that looks like, right? Like we are seeing Kafka as a black box for now. In Kafka, the messages are distributed in nature. So rather than one store, it's actually being written to multiple brokers. Internally, Kafka have to ensure, like if you have a replication factor, like I'll share much more context on it. Like I'll probably show an UI and then like share everything around it. It needs to ensure like all the replicas are received messages, and then it sends acknowledgement. So to your question, if ACK is dropped, like in producer side, it's still like the messages is sent. But how do you know the message is processed, right? Like in link to processing is where the failure comes in. So let's say, hey, you send a message to Kafka, and then if it fails, would you not process the message in database? Like that's what I was getting into. Like you can't read both of them separately, because like definitely in this case, there is going to be a possibility of redundant messages to Kafka. So rather than one single order, you will end up with multiple orders, irrespective of the failure. And you have to handle that redundant messages irrespective. So I'll move on here, right? So again, there is much more nuance. Like I have to share the use case, because in our case also, we used to send message to Kafka, updated, and then if the Kafka message is lost, it's really hard to know when a Kafka message is not sent. And then you have to like that's like let's go to a I'll just show you some. So it's almost like receive API, and then let's say create order in DB, and then let's say send message. If you just do this, if this failure happened, your downstream services are not going to process this messages. Like what I'm trying to say is, if 1 and 2 is not intercorrelated, your downstream will not see the message. And if you sort of say, hey, send message once acknowledgement is received, then sort of say, hey, update DB saying message sent. This is one way of doing it. Like this is obviously the next step, where you create an order in database, and then you send a message, and then you update acknowledgement in the database. And then if there is any failure, you have to handle it manually. And then that's why I was saying like the order sort of matters. So this will ensure you send message. Like, of course, I'm not going to touch into exactly one semantics and all of that. Even I've not personally used it. And like, I would say in distributed systems, irrespective of whatever you do, like there's going to be retries. And because of retry, there's going to be duplicates. So having said that, this is why in producer also, like you can lose messages, and then in order to handle publishing messages properly, you need to have some retry mechanism here. And then that's what I sort of extended here. And then I'm saying that you publish via a worker. In this case, it's just a RabbitMQ. And like when you create an event, you create a job, and then that jobs publish the messages, and then with acknowledgement, it can process it, it can do some activities, so that way you don't affect the API. And also the DB operation is like much more synchronous, but still both of this is reliable. And obviously this 2.1 and 2, like this job retry, it can again fail, but it will at least ensure that the message is available in Kafka. Does that make sense? Like any questions? Again, feel free to shoot. I'll keep checking in chat. Any questions? So sorry, just curious. Like anyone not even touched Kafka? Like have anyone not touched, like sent a message to Kafka, even in a Kafka console producer? Have anyone like is anyone completely new to the ecosystem? You can just drop a message. Okay, I'm gonna assume everyone used it for a while. So in this case, right, we have I have a UI running on top of my Kafka cluster. I have a local Kafka setup running, and then what I have is a bunch of topics, and then like ignore the brokers, and then I have some consumers, and multiple producer can actually produce data. So let me just go to our time data, and then like I'll probably show you. So here what I have is, sorry. Okay, yeah. I'm not touching a lot of code, so if you have not written code, that's perfectly fine. Yeah, just a second. So here, what I'm gonna write is probably, let me show you here. What I'm gonna run is, if you can see, just, okay, no worries. I hope you can see this, but I can either run a console producer, and then the topic could be as time data, and then we can send messages manually, or like I'm just sending a lot of messages with watch. It's just gonna send messages recurringly over here. So let me just run console producer, and then here what you can see is there is a consumer which is running, and then when I'm actually sending messages here, message 0, message 1, message 2, you can see, right? Like this is a single consumer, and then this is a producer which is sending time data, and then I can actually extend it to console producer, and then I can say clear, message 4, message 5, message 6. You can see, right? Like there is multiple streams into Kafka, and then here, as of now, I have a single stream, but of course I can spin up multiple consumers. We can check it at a later point of time. And then here, if you notice, this is the topic. Like this is a topic for which the data is being was published. And then like there is a lot of consumers. Ignore this because these are all consumers which is not running. And then this is the console consumer which is being run right now, and then like that's what you were able to see in pane 0. So yeah, like in this case, we don't have any retries. And then if you suddenly kill the Kafka, the producer will obviously fail. But I mean, don't worry about the syntax here. Like my objective was not to share code, but like just look at the few lines, and then you'll be able to write look at what I'm saying. So it's almost like this is the right messages, and then this will ideally be a job. Like here, what I'm doing is for thousands of things, I'm actually sending a message called like message with -I, which is the index, and then I'm just writing messages. And where I'm writing messages is actually in Kafka. And then after I write 1,000 messages, you're done. So let's say, like I'll just check here. Yeah. So I'll show you that. I mean, it's just a wrapper. Don't mind the syntax and all of that. Okay. So I have something called Kafka, like it's just a same consumer I had, which I showed you. And then what I can actually say is produce, and then I can say time data, which is the topic which we were talking about. And then I can actually, let me just verify, produce. Yeah, so this is done, but let me just, you can see, right, like it's pretty fast, but this is something you can extrapolate to, like even you can have multiple consumers and then Kafka is going to handle it seamlessly. Here the latency is super small, so because of which we are not able to see it, but this is the point, right? Like I can actually keep producing messages, and then here you will be able to see a lot of messages coming over here. So if we go here, and then if I see messages, let's just see whether, yeah, I don't know what order it is, but probably it's oldest first, I guess. Yeah, okay, newest first. And then as you can see, like the multiple messages are being written, and then you can see it being available in Kafka. And then you can use any libraries. There is something called Libardi Kafka. And then what I am using is actually Kafka Go. Java has like officially Kafka documentation mentions some libraries like Confluent Kafka Java library. You can use pretty much all of that and then to publish messages. Yeah, like that's how you produce. Like produce is as simple. Like the only takeaway here is when you publish it, assume the publish can fail, and then you have to handle with some retries. And of course, like internally, the library has some means of retrying. But there is tons of other reasons where the Kafka message can fail. It could be there is some limits on Kafka message size, or it could be like let's say, hey, you're trying to publish to wrong location. There's nothing like contract here. Like I don't know whether like somebody used any schema validators, but in this case, it's more like, hey, when you publish, assume it's going to fail, even if internally the library has some 100 retries, it can even fail after that. So in that sense, like you have to have jobs if you want to ensure 100% the message is sent to Kafka. Like that's the producer part. I'll take questions. Like, by the way, feel free to like, I mean, since you folks are like it's a small group, like you can just ask me and then we can have a discussion. Like you can even keep your mic unmuted. Any questions here, or does it all make sense?
It all makes sense so far.
Cool. Anyone else? Okay, awesome.
Just one question. Sorry, just one question here regarding the retry mechanism.
Yeah.
So how is the retry mechanism of Kafka? Is that configurable, or is that some kind of an exponential backoff retries, or?
Okay, so the Kafka doesn't have a retry. Where the retry happens is actually in the library end of the producer side. So let's say I'm just gonna open a Kafka Libardi Kafka Go. So let's say let me just open a different client. Yeah, so this is what I was using. So you can actually see, right, like there'll be some like ignore this, but internally library has some configuration. I think by default it's usually like big number or it's even negative, but that is the configuration you can configure, but it can help for like a timeout failures and that sort of stuff. But for any other reason, let's say, hey, the message length or something is out of the like bound, those sort of failures you need to put it into DLQ, or like you have to put a limit on the retries also, right? It's not like you can assume it's going to work forever. But the point is, it's on the producer side, the libraries support it, and then like Kafka just receives it and then it distributes across different partitions within its topic.
Okay, so by saying producer, do you mean it's like the code that we are writing, the customer
Yes.
service itself? Okay, so basically when we are posting message to the Kafka, let's say Kafka endpoint, we need to make sure that we have those retry mechanisms in place and not rely on the Kafka retries?
No, you can rely on it, but I'm saying still, like it's good to have one more layer
Okay.
depending on the reliability requirement. Let's say if it's a location publishing event, right? I don't care if the message is lost, but if it's a payment, if it's order transactions, I don't want to miss the message. So that's where the reliability sort of kicks in.
Okay. So, okay. So sometimes, like, what might happen is, let's say I'm like my customer service is producing a message and I'm for some reason putting it into a wrong queue, or let's say that queue in which I'm posting the message expects a different schema, right? So in that, like I did a mistake by entering the by putting the queue name at right. So like I wanted to put it in the orders queue, but I put the message in the location queue. So will the Kafka still keep retrying that message, or it'll just say once that, oh, you've put it into the wrong queue or something like that?
Right. Okay. Go on. Sorry, finish.
Yeah, I was just saying that, sometimes we know that, oh, this is a failure, and even after retries it is going to fail with the same error. So we don't want to retry it multiple times. We just try it once and it's out, right?
Right.
Unnecessarily retry just uses up our processing everything, right? So is there some sort of mechanism that Kafka provides, or the producer? How do we do it basically?
Yeah. So one simple thing. There is no concept of schema here. Like by default, I have not used any schema validator. That's usually like there's no schemas. Like in personal sense, like we used to publish protobuf messages into Kafka.
Right.
So here, as you can see, I can type anything. I can type numbers. It doesn't matter. There is no schema here.
Okay.
In terms of producer, it's the same thing. Like here, I was publishing some random thing. This is not JSON. This is nothing. It's just a random message, right? So in this case also, there is no schema. That's as simple as that.
Okay.
When you produce, I always associate topic, if you noticed. So
Yeah.
in that sense, there is nothing like, hey, be published to a wrong queue. Like whenever you create a producer, you associate a producer to a topic. So in that sense, it's always going to go in the right topic. If it goes in a different topic, because if you redeployed with a wrong configuration, of course, that's something like you need to sort it out manually. There's nothing like contract associated with topics here. Cool.
And the consumer that reads from that topic, let's say I posted that message into a wrong topic, and then the consumer reads from that topic. So that consumer, I mean, we'll get a failure on the consumer end, right?
So we'll get back to that. Like I'll come to that in a bit. So let's say, consumer contract schema failure. Like I'll come to that in a minute. So now we understood that, okay, Kafka can have a topic and then we can publish messages. And then there is this bunch of consumers you can consume. And let's say, like, I mean, like, let's simplify it. Like I'm not even touched partition, but I'll share context if you, like in a while. So in this case, like as we have seen, this is a multiple group ID. Like you can just call it as a group instance. So what Kafka does is, if you give a group ID and then if you create multiple consumers with the same group ID, it actually distributes the topic within that consumers. I mean, you can assume, hey, all of this is consumer for same topic. Instance ID is different. Like there is a small nitty-gritty detail, but like I'll just go here and then run. Sorry, if it's too much, I'll run console consumer. So this one I don't have any like group ID associated, right? But let me just run something with the consumer group ID. So in the same place, like I'll show you what it is. But consume, and then you can see group ID is consumer 0. And then I can run it again. And then I can run it again. And then I can run it again. So as of now, what we have is we have 4 instances of running. As you noticed, all of the messages is actually sent, because of which there is no other data coming in. But let me just go here and then say, yeah, let me just go and produce a message and then see how it works. Yeah. Sorry, like it's too many tabs, I know. But if you can see it, the point is the messages is split in this consumers, right? If you can see here, it's the same topic, but there are multiple consumers running. There is a reason for like why this consumer is not consuming messages. I'll come to that in a bit, but this is the consumer group basically. And then like all of this consumers is associated with the same topic, and it just gets messages. Like you can almost think of it as a imod number of instances. Yeah, so here, if I go here, this is the time data. Okay, like the name was different. That's why it was wrong. So here you can see, right, like it looks like a single consumer, but internally there is multiple instances running. But yeah, that's the context. Consumer group is like a group of instances consuming the same messages, and it distributes the messages in across. Yeah. So now if I go back here, yeah, that's what I was talking about. In this case, I have defined a consumer group, and then if I sort of describe what it is, it's the same consumer, but it is associated with a different topic. Of course, we haven't touched on partition and offsets and all of that, but if you could see here, 3 instances, same topic, and lag is basically like how far are you in terms of message consumption. But like we'll get back to the reliability part, right? Like here, what can happen, right? So here, let's say, hey, you consume different partitions in a topic, and then you try to do some processing, and then you try to publish into a database. And then let's say, hey, one particular instance failed to push the message into a database or process it. Now what happens, right? In Kafka, like if you create a consumer by default, it's assumed that the moment you receive a message, you've successfully processed it. So the Kafka doesn't wait for you to do something and then say, hey, the message consumption is successful or not. Like its responsibility is, hey, you've received it, done. Like, and then like this failure, how will you deal with it, right? This is where the Kafka gets a little bit interesting. In our published case or in a usual case, what we would end up doing is, again, okay, create a worker, create a job for this particular message, ensure the job is written to database or ensure it's called to a different API. But that something is not needed in Kafka. Kafka has a different mechanism called commit, where like I'll go back to this, right? Like this is producer flow. And then in terms of consumer, it has a explicit means of saying, hey, what is considered as a success. So here I have receive message 0, and then I have, let's say, write to DB. And then this particular consumer is, let's say, consumer 0. If this fails, there is a means to say that, hey, you know what, have not done this writing, or it could be like processing. So this is like a bunch of stuff you need to do, right? So if this is not done, Kafka can actually send you the message again. Of course, like which consumer, it depends on like what it is assigned and all of that. But the point is, like here, there is something called a commit. And then let's say like in a message, now we know like I'll come to what is partition a bit. Let's say offset is just an index, like just think of it as for now, like we'll talk in detail about it. So now this message is supposed to go to a particular partition called 0. And then I have to sort of say that, hey, I have consumed till this offsets. Like if imagine if you have a stream of messages 0 till 10, and then there is like 11 till 20, if you say that, hey, I've consumed 10, then only Kafka is going to send you 11. If not, Kafka is going to send you the same set of messages which you haven't committed. Let's say the last successful commit I have done is, let's say at 5, like last commit. Yeah, sorry, like this is just an ad hoc, like I don't have any slides for this, but if you've done a commit for 5th message, it's going to send you the messages from that point till 10 for you to receive it again and process it again. So what that means here is you can actually club the processing right into DB, whatever you want to do. And then if that is not done, don't commit it. And then like Kafka will resend you the message. That's where the reliability part comes in here. So I'll show you like just exactly on the same sense, like I'll show you a quick code. Again, ignore the syntax. It doesn't matter at all. But as you can see here, like I'm in a loop, like a for loop. I'm fetching messages from Kafka and then I'm processing. And then after processing, I have to commit it. Let's say I have an error. If you have an error, you can actually say return some error. Like, I mean, in Go's context, like this actually is returned, like ignore this. But the point is, if you don't want to commit, don't commit, and then Kafka will resend it. And then this is what the processing you can do reliably, and then Kafka supports it internally. That's the point. So fetch message, process it, and then commit messages. There is some other configurations we'll touch here, but yeah, I'll just see what questions. If there are multiple consumers processing orders, how do we handle the case where we don't do duplicate the work? Correct. So duplication is actually an interesting topic. You always have to assume there is going to be duplicates because it could be in the producer worker job, or it could even fail here, right? Like Kafka, let's say you send it and then you send back, like you process it, but while you send commit back to Kafka, the Kafka network failed. So it's possible that like you end up consuming the messages again. In terms of payments or any other critical transactions where you don't want to repeat it, of course, you need to manage some idempotency. Like idempotency is the answer there. Like you need to manage it with some explicit order ID or explicit unique ID, and then always check if this is already processed, don't process it. So what you will end up doing is, hey, get the order, check is the payment made for this in database. If it's already done, ignore. If it's not done, process the payment and then continue. I hope that answers. So now we'll go back to this question of, right? Like this question of contract. What happens if the contract fails? So it's sort of interesting, like where, like I sort of mentioned, hey, there is a stream of messages. And then at every point, you need to say that, hey, I have successfully consumed till this point. So that means at any point, if you feel, you're not going to proceed further. So that's usually called Kafka lag. Like I'll show you in the UI as well. But if your service contract expectations fails, if there is a noisy or like a bad message which is into the topic, you need to like build your consumer around it. If the Kafka validation fails, you shouldn't just keep retrying. If the validation fails, you know that even if you try millions of times, the validation is going to fail. So you have to put that in a separate DL queue, like it's called dead letter queue, or put that into Google Cloud Storage or any other place where you can manually look at it or send alerts, but continue processing. Like, so I'll go here, right? So let's say I have something of this. Okay, yeah, it was different. So let's say I'm just saying, instead of this returning error, all you will be doing is continue. Like, don't stop processing, keep continuing. Of course, here you will have to write DLQ, write the message, and then act on it manually. This is what you will have to do. Yeah, that's the answer for that. So now like I'll show you here, right? The consumers, like here you can see, right? Like this is a random consumer, and then this is a consumer group. And then this is the members you can see, right? Like the members is what I was saying, like it's number of instances, or like you can call it like number of members who's consuming from the same topic with the same group. And yeah, if I kill it, it will become 4, or like we can increase it. Yeah, now you can see like it's become 5, like that's concept. So the reason why this is also super awesome is, like, imagine you built your service and then you load tested it, and then you've done everything for 10K messages per second. But suddenly, like the producer or some new company onboarded your product, and then rather than 10K, they're sending 20K or 50K messages per second. This sort of consumer group replication and then partitions helps you scale, like how in Kubernetes you can do auto, auto scaling. In the same way, you can scale your consumers, and then you can just easily handle it. You don't have to worry about what do you call that? Like, hey, what happens if the scale goes high? It's much more easier to adapt to it. Of course, there's some nitty-gritty details, but I'll stop here, take questions, and then I'll move on to the details. Anything you have here? I'm assuming no questions in that sense. Okay.
Mm-hmm.
So let me just go here and then see. So there is a concept of, I mean, it's simple, right? Let's say, like, let me just go and see whether I have an image for this. In this case, I have like 1, 2, 3, 6 partitions. And then you have 3 consumers. What you can do is you can allot 2 partitions for each consumer, and then that's how you distribute it. But let's say my number of consumers goes down to 1, all 6 of the partition messages goes into the same consumer. Now let's do the extreme, right? Like I have 6 partitions, but I have 10 consumers. Can you consume all, like, can you consume messages in all 10 consumers? No, like it's not possible. In Kafka, if you have X partitions, you can only run X consumer instances. So if that doesn't also scale, like that's why like you would have read so many articles around scaling up partitions for a topic. There is a catch, like in that sense, don't start with 100 partitions, because you can't scale down partitions. You can always go from 5 to 10, 10 to 15, but you cannot come from 100 to 5. And there is also a lot of side effects associated with like having a lot of partitions. Your cluster have to scale, a lot of configurations you need to be wary of and whatnot. Yeah, that's one detail, but I'll try, like now having said that, that is why like this particular Windows on the right is not able to receive any messages. So even though like I have produced all the messages, you can see it's almost pretty much goes into these places. Let's just see whether you're receiving it. You can see, right, like it just receives in a particular place. Let me just see whether I have this here. So now I'll try to scale the partitions. Like I think let's just see how many partitions you have here. This is the time data. And then as you can see, I only have a 1 partitions. I had like 3 partitions for the other topic, but this was a wrong spelled topic name. So let's just scale it. Like hopefully, like I have the command. Scale Kafka config. I'm just trying to, like, I think I missed the config partition. Yeah, so let's say, yeah. So if you can see, what I'm going to do is I'm going to change, let's change it to 3, and then we'll change it to 5 again. So I'm altering the topic to have 3 partitions. Okay, my port is different. So now it's done. Like it's not one partitions anymore. Like if you could see, hopefully it should be reflected. Yeah, you can see, right? Like the partitions is 3 now. And then if we go back here, yeah, I have too many things running. So yeah, this is the consumer side. Let's just run producer and then see. I'll increase the consumers again, like partitions again, just to be sure. I'm going to increase the number of messages as well, because it's possible that like the messages are going to the same partition. So let's just.
Is there a way we can control the message going to a particular partition?
You can, but ideally you shouldn't.
Okay.
I'll tell you why. Yeah, so.
I mean, I'm not sure if there is any use case also behind that.
There is, but it's very rare use case, but you shouldn't do that, like ideally.
Okay.
Ideally, it should consume. I think I am missing something in the client I have written. What I can actually do is I can actually run console consumers. Like I just quickly added that code, like just very recently. So I might be missing something. So like I'm doing the same thing, but instead of my written code, I'm running with the console consumer. And you can see, right, like this, hopefully, let's see whether it gives the expected. Now you can see, right, now this is giving expected result. It's consuming from all the location. So let me just scale it up to a few more consumers and then see whether we are receiving any messages. Yeah, okay. So now I have 6 consumers running. Now I'm doing this, same thing. Produce. Okay, great. I'm receiving all the messages. It shouldn't be happening, but okay, my problem is, like the consumer group ID I've not given. Like, let me just give it and then like we'll come back to that. Yeah. Group. Okay, I think there is a group. Group consumer new. Consumer new. Hopefully, like I'm missing something. In this case, it was consumer group ID. Like in the earlier case, let's see. Okay, so now I have the same 6 consumers new. Now, hopefully, it should be distributed rather than all of them receiving the same messages. Yeah, now it's happening slightly what I expected, but let's just see. So what should have ideally happened is like I should have received the messages in 3 windows. Like we can just look at this, whether I'm what is missing. So for this data, I have a consumer, I have something called time data, like topic, and then the consumers are fine. Like if you can see here, like only 3 consumers can receive it because of the partitions. That is what I was trying to show, but like something else I'm missing. And then if we scale it, then only properly all of these consumers will be able to receive messages in an even way. Yeah, I think somehow it's partitioning into the same, it's going into the same topic is what I can guess, but let's see. Like I'm just going to send a different message in a different format just to see whether that's going to help us. Nope. Okay, I'm missing something, but you get the idea, right? Like that's the context. Like, let me just see topic. Yeah, it's all fine.
So are there any kind of tips for provisioning like a good balance between like producers, consumers, and topics? Is there like a kind of good heuristics or rules of thumb, or how do you, are there any kind of tips for that?
Yes, so I would say always start with less number of partitions. The answer is like no straight answers, right? Like always what I suggest is run load testing. The load testing is the one which is going to give you better answers. Let's say if you expect 20K requests per second, do that simulation and then run with a single consumer. Then you will see that like obviously single consumer can't scale, but don't suddenly scale it to 20 consumer, scale it to 5 consumer instances. So that means obviously you should have higher number. But if you ask me a magical number in our org, 12 partitions used to work pretty much great for a lot of topics. I've seen some companies using really large partitions, but we never had it, except one case where all of our drivers, they used to send locations every milliseconds, few milliseconds. And then that data was really huge. For that, like we extended to 50 partitions. But pretty much apart from that, it's good. And in terms of number of consumers, you don't have to worry much, but because you can always start with one consumer, and then as you scale, like you can increase it. And that's where the like consumer lag and a lot of other thing comes in, right? Like I'll just quickly show this. So let me see whether I have it running. Yeah, I have something running. So here, if you could notice, there is something called consumer group lag. And then for this, it's a concept called like, hey, this is consuming messages and then it's lagging. You have to track these and then like see, hey, if you're under the lag, then it's perfectly fine. If you're not, then you have to increase it. So here you can see, right, we actually sent a lot of messages. Like we have sent like what, 35K messages, but it quickly processed. If you are not able to consume it, and then if this lag is for a longer time, then you have to increase the partitions or increase the number of instances for your consumer groups. So that should be your answer, like load test, predict, and then do this real-time monitoring and then have alerts. And then like you can take appropriate actions.
Okay, thank you.
Yeah, go on.
So just one more question. The scaling, can that be done like automatic scaling kind of thing for consumers and for topics?
When you add a new consumer, Kafka automatically redistributes the topic. So that is not an issue. Okay. But for the consumers part, like you have to add it manually. Like, I don't know, like if you have Kubernetes, maybe you can do some auto scaling based on if this metrics goes high, increase the number of replicas. But apart from that, like pretty much like you can live with like increasing consumers manually. Like it's usually fine, like it rarely happens, right?
The reason I ask is like, let's say, during certain times of the day, there are more requests coming in, and other times there's less requests coming in. So maybe in the morning we might need 10 consumers, but in the evening or off business hours we need just one consumer. So we want that auto scale kind of functionality.
Right.
So
yeah.
just
so,
one. Yeah.
So there, right? That's the point. I don't think you have to worry too much on what do you call that? That scale, because if you run one consumer, you should be still fine consuming 20K, 30K messages. I would say you don't have to worry, like don't treat it in that level where I have to scale it up and down every night. Run two consumers and you should be fine for like even millions of messages per minute.
Okay, so a follow-up question, sorry. So how does the costing work? Like I'm pretty new, so I don't know how the costing and things that work. So let's say I have one consumer versus two consumers.
Right.
So yeah, so how is is there a different costing, and can you talk a bit about it?
I'll come to the, I don't know whether you're talking in terms of price, like cost of infrastructure or latency.
Price, money.
Okay, I'll leave that conversation for later. Like,
okay, sure.
I don't know whether Joe is still there. Like Joe could answer in terms of Confluent. I can answer in terms of running it on-prem, but like we'll leave that for later on. I think it's still. I figured the issue, by the way. I think the issue is like I was always publishing the message to a single topic. That was the issue. Let me just see whether I can fix that. Because where I figured out was like I went in and then I saw all the partitions are like all the messages are sent to the same partition. So that's why only one consumer was able to consume it. So now if we say that, I don't know, like let's just see. So ideally I should be running multiple producers of this. but let me just see what is the minimum way I can add this. I'm just trying to see here, write message, Kafka message, partition. Yeah, here I can try adding partition, and then I can try adding file, something of this sort. Let's just see whether this works for us. Fail to write messages, writes must not set partitions in Kafka message. Yeah, it's because like I am writing directly to the leader. So let me just remove it and then see whether I have something. I have context network address, partition. Okay. Like I'm just trying to showcase that, so that way I thought it'll be better. Context. Yeah, okay, fine. So I'll directly do this. You know what? I'll directly do this. Just bear with me a few minutes. So I'm just gonna run, I don't know, this, like now I'm gonna publish to 2 topics. Ideally, I shouldn't be doing this. Like there is a different, like we can check it directly. Let's see whether I can find it. Produce writer. So this is what I'm using. You can see, right? Like it's set, partition is set explicitly. That's why it was a problem. To connect to later, we are not later. I don't know whether, like, so usually what we have to do is create multiple instances and then randomly, like for every partition, you can publish it. In this clients, that's how it is. But in other Kafka clients, like Go client, I don't have to mention partition. So that is what I'm trying to figure out, because I'm trying to connect and then do it. Like that's the issue. It's a bad way of doing it, but let me just do it. It's fine. So here I've just made the mod 5. Sorry. Yeah. Just bear with me. Yeah. Okay. So now let's see whether I missed something. So I'm just gonna say, I mean, much better, right? Yeah, I'm doing the same thing, but every time I'm making a connection, which is a bad thing. But let's see whether how it looks here. Like I can actually do this. And listen, for each times, for each partition, I'm actually sending 1,000 messages. This is another way. Let's see. Because every time the connection making is going to be bad, right? That's why, and it's again, it's sequential. Probably once it's done, it's gonna happen. I'm just trying to make this also concurrent. Let's see. Yeah, so this is fine. Don't worry, like I'm just trying to write some bunch of messages in a different place and then seeing whether we show the result. If not, it's pretty odd. Yeah, we've come to a different set now, but let's just see what I'm missing. Okay. Oh, okay, so this is a different consumer. Like now it should ideally work. Like we can verify it here, and then hopefully it should be fine. Let's just try it. If not, never mind. Like we'll probably do it at a later point of time. We can try partition. All the partitions are this. Let me try newest first. Yeah, here you can see a bit of messages 1 and 2, right? Like that's the thing. Yeah, you can see a bit of messages. So we can just try running it once, and then if it doesn't work, I'll just ignore it. So now I'm running with a custom consumer I've written. That's the only difference. Consume consumer group. it's consuming all the messages because there was a lot of lag, and then now it's trying to recover from it. But yeah, like ignore it, no worries. Like I think we'll do it later. It's not showing up what I was expecting because I'm missing something in the library API contract. That's not because of the Kafka. But anyways, I'll get back to this. So here the only point is assume that the Kafka message processing can fail and then commit it in a synchronous way. So there is something called auto commit offset in every library. You should disable it and then do the commit offsets manually. Like that's the major part. Yeah, so I'll just check what questions you have. Kafka over RabbitMQ, I'll come to it. So going back, right? Like I think like if you noticed, like I think pretty much topic consumers and all of that is fine. The offsets is the indexes within each partition. So if I go here, I think if you also get that, yeah, you can see, right? Like there is replicas is not there, like it's a server side thing, ignore that. But there is an offset which is available here. Like that's the difference. So in here you can see, right, like the data is distributed evenly, and the messages are also like would be in different even partitions. And then within each partition you can see the offset, right? Like it's like an index. And then this is what I was saying. So hey, at this point, if I consumed it, you have to say it's consumed. If not, it wouldn't go further. So the moment you consume 10, then you have to commit 10 is done, and then the Kafka moves forward. If not, it keeps resending the same message to your consumer. Yeah, in terms of like what do you call that? Like I've talked a lot on like how to handle distributed systems and some scaling aspects, all of that. Like I'll share the talk and all later on. Now, if coming to the pricing, right? The Kafka is a cluster. So in terms of cluster, you would need, let's say, 3 brokers or 6 brokers. I have not personally run Kafka cluster without Zookeeper, which is released, but let's say if you have 6 brokers, you need 3 Zookeeper machines. And then your cost is mostly for that 9 VMs. In terms of Confluent, of course, like you need to add into ingress and egress cost. But I would say if your scale is the problem, I think like you don't have to worry too much on this. It's just purely VMs. But like I don't know whether there's a different aspects of cost. Like if you want a quote, I think you should talk to Confluent. But I think with 6 brokers itself, I've seen so many companies scaling. And I don't think I think it'll be cheaper than like, let's say if you're running a cloud Kubernetes or high scale Kubernetes instances. So I think like you will get a lot of leverage, but yeah, happy to chat later. Like, yeah, we should sort of discuss this offline. Any other questions, like feel free to shoot, like discuss. Benefits of RabbitMQ versus Kafka. I would say RabbitMQ is a simplified version. I've not used RabbitMQ for a long time. I think I almost forgot. I think there's a nitty-gritty details around partitions, like how the queuing is managed in RabbitMQ. I don't know whether they have this concept of like a random consuming groups adding and then dynamically adding all of that. It's those details you need to worry. But I think if you're small, you can start with the RabbitMQ as a like event-driven system as well. It's perfectly fine. Even Redis has a pub sub means. You can even use that, like if your scale is small. Kafka is super helpful in terms of like billions of messages, right? Like those components itself needs to be scaled in order to handle that. And then this sort of like architecture is evolved in a very different way in Kafka. I didn't touch it, but it's like I can almost say something like, hey, consume. I can say star booking log. I can consume a regex based topics. So what this is going to give me is any bookings logs is going to come to me. So today we used to have a consumer where I measure end of the day what is the let's say revenue. And tomorrow you introduce a different order, like from ride hailing, let's say you have a food or some kind of a different means of ordering. this consumer will still work. Like you don't have to do anything except for scaling consumer instances if you really need it. But I think those sort of things is really nice in Kafka. And like adding more topic and like setting up multiple Kafka clusters, mirroring, like there is this lot of context around like, should you use Kafka as a storage versus how would you use Kafka as a transaction? I am personally a fan of Kafka as a transaction, like store less than, let's say, I don't know, 7 days or 30 days, depending on how much load you have, versus if you store for months. Like I know there are a lot of querying components out there, but like Kafka sort of does it well for like a live event driven systems, whereas like even if it goes down, even if one broker goes down, it can handle all of that failure cases very well. So in that sense, like look at it like specifically if you have questions, of course you need to look into it. But I personally feel like Kafka can scale for a much more higher like performance sense, like as well as latency sense and load sense. It can scale much better than like, let's say, RabbitMQ. I've seen a lot of RabbitMQ based production instances. So yeah. Doesn't reactive extensions to Go help handle? What do you mean by reactive extensions, Ravi? Hey, you can unmute and then you can sort of answer. Okay, I think you're talking in terms of reactive programming as a means. I've not used much, sorry again, but I mean the reliability is more around like in terms of like it doesn't matter whether it's a reactive async function or it's a job, right? So in terms of consumer, Kafka helps a lot, so it's fine. In terms of producer, maybe you can use it. I have not used any of such libraries. If that is going to give you retries in a seamless way, of course, use it, not an issue. But yeah, apart from that, I think the reliability, in my opinion, is more of a concept where you have to ensure there is no bottleneck, there is no single point of failure, and then you assume everything is going to fail and then you handle it. So that is different. And then it can even fail in reactive Go, right? Like if you use reactive Go and then try to write something in database, if it fails, of course, you need to have a retry mechanism. If that library gives, awesome. If not, you would have to handle it, right? But yeah, I've not used it. But with Go, yeah, I don't know like how many of you used Go personally, but like it can scale way better than any other languages, and we were able to like handle much higher load with like 3 consumer group instances. Unless your DB writes or external API calls takes time, like at that point, like your bottleneck is different. It's not library or your service. But yeah, I use it, try it. Yeah, any other questions you have? Yeah, sorry, I couldn't show it. I quickly wrote up something, like I haven't, like all of my code base is like not there. You should be able to achieve what I was saying. But like I think in the producer sense also, like we should have been able to see it. Like console, I'm just gonna see whether this is gonna help, but let's see. But it's already a lot of messages, so find data. Yeah, I don't know why it's only going to this particular partition. Probably that's why like you're not able to see it, right? You can see all the messages received, but it's only going to 0 partitions. Yeah, that's the odd part. Partitions, I'm just gonna say it's 10. I'm increasing the partitions. Yeah, I don't think it's fine. Like I'll like I'm missing something for sure. That's why it's not happening. But yeah, you can check it at later point of time. Any other questions? I'll take it. Can you summarize what the common fit? This was my last talk. Like I gave a talk in Kafka gotchas and stuff. Probably I'll share it with you. But I think it's much more a detailed topic. Like I've talked much more around configuration and all of that. Probably I'll share that link.
Oh, you have it on hand. Very helpful.
No, like I've been giving talks in Kafka and around Go for a while, but yeah, it's a large topic. That's what I'm trying to say. If you manage producer, I mean, okay, I'll tell you my famous two things, right? My famous two things: don't expect ordering. People expect ordering in distributed system. That's a myth. Be wary of it. If somebody says, "I know Kafka," and then I can, it's not about Kafka, but like in distributed system, it's hard to manage ordering. That's one. And the second thing is always there's going to be duplicates. If you can get away with those things, I think pretty much like I've seen even some power users trying to build system around ordering, and then it fails terribly. That's a biggest myth, I would say. But let me see. I don't know what I have. I have a talk, but let's see. Gosh. Yeah, but yeah, like there's not a lot of details around. Like if you're doing a server management, it's very different than if you're only touching services. It's very different. So in that sense, like if you have any like give me more context, that way I can share it. But yeah, don't expect ordering. Assume redundant messages. Assume out of ordering also. That can also happen. In terms of event-driven system, these are all like I would say is really important. Yeah, should.
Hi Dinesh, one more question. So it's related to ordering.
Yeah.
So am I right if I say that if we want to achieve some kind of reliable ordering, then when we fetch the messages from the topics, maybe those messages can contain some kind of a correlation ID and an order ID, and maybe somewhere in the consumer we can write code so that we can process those messages in order. Am I right in saying that, or even then it's kind of not achievable?
Okay, so the thing is, I mean, you can have a correlation ID, you can group it internally, but let's say, I mean, I'm just trying to go to the consumer side. Let's see where I have it. Yeah. So here, let's say if I add another consumer group, right? What happens? Like then you will, there is no logic. Like suddenly the messages will go there, and then like you can't do mod. Like if you like, that's why I said don't do custom partitioning. Like it's really bad idea, because it's possible that like one particular partition can be loaded and then that consumer can't scale. Like I've seen that happening with some people. Like I can also show, like there is a diagram, I guess. But I mean, handle idempotency. Like I would say, like one thing you can use is timestamp. Use timestamp as a means of sequencing, and then ignore the older messages or do processing accordingly. But I don't think you can achieve like 100% ordering, because you're gonna get messages in a poll. Hey, every 5 seconds, give me messages. If that messages is coming in like that 5-second chunk, great. If not, you have to store it in memory. Then how long you're gonna wait for a missed message? It can come after an hour also, right? Like depending on how you have implemented. So yeah, just handle with idempotency, like handle for cases in terms of like critical payments and all of that. It's gonna be tricky, but like for other cases, usually it's not gonna happen. But of course, like the percentage, right? Like how much is consistency important for you versus like performance? That's the thing.
Yeah, I think this is common problem with Azure queues and Azure Service Bus as well. So we have these kind of sequencing and ordering issues there as well. So, I'm pretty sure Rabbit. Sorry, go ahead.
Yeah, no, any queuing system, any retry system, you can have a HTTP API call, like customers retrying. It can happen anywhere. The network failure is the biggest thing. My favorite is, like I don't know whether you folks read it. Like there is a problem called Byzantine text generals problem. I'll just go read it. Like there's papers, there's tons of articles. It's still unsolved. The network failure can happen anywhere, and then it's just super hard to solve it. So that is what is pushing. It's almost like I keep telling people that, you know what, like you're not solving the problem. You're just moving the bottleneck or a problem into a different point. That's it. And buying. But yeah, like the ordering and all is very tricky. I know, like if somebody else used Kafka in a production with exactly ones and all of that, maybe they can mention, but I have not done that. Let me see ordering. yeah, okay, I have something. Yeah, this is what I was saying. Like if you do some custom partitioning, right? I don't know how much is visible to you.
Yeah.
But if you end up doing some custom logic, if you do some customer ID mod, and then if you push it, like there are some cases I've seen people trying. But what can happen is if you do geological partitioning, let's say, hey, I'm going to send US-based orders into one partition, Canada-based orders into one partition, and other location-based order into their partition. Customers, where customers exist more, that partition will be overloaded, and it doesn't matter what you do, that consumers cannot scale. So use round robin, it's perfectly fine. That is actually like the solution for these problems, and that is the default. Like, so don't mess with that. Yeah, ordering. Yeah, I think it can happen, fail anywhere. I think I don't know. This is what I even forgot the context. It can fail in the publishing. It can fail in the ACK. It can fail while reading. It can fail and mock job is done. It can fail anywhere. So in that sense, you're gonna have redundant messages. But yeah, like build the system and like that's why I said the basics is assume everything will fail. If you think that, oh, I'll never receive out of order messages, then you're gonna end up with a higher problem, because it's really hard to verify, hey, is there a message loss in Kafka? Like that's really the problem we've tried. You need to have some other means to, like, if you send 1,000 messages, can you tell me 532 messages gone? No, you can't. Like, it's really hard in such large scale. But yeah, like any other questions? If not, yeah, I'll move on. I think we are probably on time. So yeah, like I'll do a shameless plug as well. Like I'm founder of like a Rely On Metrics, like where my aim is to help companies with reliable infrastructure with open source solutions. It could be observability. It could be around Kafka or Postgres. Like in terms of high scale, what I've seen. But I'm trying to like build some solution as a product. Like if you have any questions, or if there's anything like which interest, like would be happy to chat later on. But yeah, like even schedule, like just hit me up on LinkedIn if this is an interesting conversation. I'm always happy to chat more around distributed systems and DevOps and infrastructures and whatnot. You can hit me directly on Twitter, or you can find me on LinkedIn. And then, yeah.